Hi, I'm Bob Race. We're going to talk about the analysis and layout software. How you get the image into the software, how you zoom it, how you lay out your image, how you get the top and bottom of walls, plotting the walls, and then finally designing the walls. You'll find it's going to be a nice tool. It's pretty fast. Let's start from the desktop. Here's our icon for our software, analysis and layout. Here's the icon for the plan view that was sent to us we want to design. We're going to double click on the program. Splash screen, nice magnum stone wall in the back, natural limestone in the front. We want layout because we want to design the wall. We want to produce that CAD drawing in our quantities. Except the disclaimer, the program comes up. The menu over here is layout and design because we've got plan view, wall layout versus the analysis, which is a two-dimensional design. Okay, let's go to plan view. We'll expand this full size. File, convert a PDF to an image. Sample plan is what we want. It's going to come in. It's going to zoom to full screen. There's a scale bar. Let's check our scale. Click our ruler. We measure from 0 to 60. 6.26 feet, not what we want, so we need to scale the drawing. That's 60 feet. We'll erase our old measuring bar up there. Click the ruler. 0 to 60. 60.00, perfect. Now the drawing is to scale. We're going to select our P line, or polyline, and we're going to click over the wall layout. I'm just going to click to the corners here. We'll click grade points there. End of wall, double click. There's our wall layout. I've turned the bright line red. I've winded it to 3 so you can see it. We've got more grade points here that I didn't click on. We've probably got some slopes in here. We've got the end of the parking lot. We can add points or delete points with these buttons up here, the pen. So we click on the add. I'm going to point there. I don't have anything here. Slope, so I'm going to say you're going to start at this point, continue around, probably up to this point here. Parking lot ends here, but I'm just going to carry the load up to this end point. So we're done there. We'll click on our select line. Let's get our points. I click down here, get points. I'm going to number the points. Now, if I leave this default, this is set up for a 1 to 20 scale. You can see the numbers are pretty big. They work, but maybe I don't want them that big, so I'm going to make them 0.5. Click the numbers again. I've got to select the line first, number the points. They came in much smaller. Easy to read. So 0.0, 1, 2, 3, 4, up through there. Pick the line again, get the points. There's a coordinates of all the points on the plan. Now we start at the lower point, the bottom of the wall, and we work our way around. 583, 581, 582.5, 583, 582, down there. So the bottom of the wall was, top of the wall was 578, bottom of the wall was 577. I've got a corner at point number 2. It's an outside corner. I've got another point, outside corner at point number 3, and another outside corner at point number 5. That defines my geometry. The last thing we can do, we'll select the line. We'll say plot coordinates. And what this does is, if I zoom in on it, minimize that, at every point it gives you the station. It's 112.7 feet from the end. The top was 581.5. The bottom was 571.5. Great way to check your numbers. Good way for somebody else to go back and check you that the input matches what's on the drawing. That part looks good. Now we are going to go bring our input form back up, and we're going to send it to the drawing. Now we go to wall layout. There's all the input points you had. Now we want to look at slopes above or below the wall, live load above and below the wall. We go back here, pretty level through here. I do get a slope in this area. What is a slope? Let me measure out. If I go out, say about there, 18 feet, it drops 1 to 2 feet. Go back to wall layout. Slope length was 18, drop 2, it's a 6.3 degree slope. And that started at station 74. So 74, it's right here, toe slope, 6.3 degrees, 18 feet long. And I say I don't have a bench below the wall. Come to my next point at 127. The slope's a little bit steeper. I'll come out there. Looks like about 6.5 feet, and it's dropping 1, 2 feet. Looks like kind of a 2-to-1 slope in here. And that's at station 112. So I go back here, station 112. Call it 7 feet, drop 2 feet, 15 degree slope. So we'll call it 16, goes out 8 feet, and 0. We come up here, probably at this station, the slope looks like it levels out there. So at 156, no slope. 156, no toe slope. And this is going to carry all the way to the end of the wall. 74, we said we had toe slope. 35, we don't, so we'll put a 0 as we lead into it. What the slope will do, it'll gradually go from 0 up to whatever the slope was here as it transitions between the two. Surcharge loads. We've got a parking lot behind the wall, comes around, and I'm going to say it goes all the way up to station 212. Wall layout. It's a parking lot. I'm going to put 150 pounds, 3-foot offset, 50 foot wide, all the way up to station 211. At 211, my live load goes to 0. So it will carry the surcharge all the way through here, stop it at this point, and coming around the end. That's our surcharges. That's our slopes. Let's look at our default input data. I'm calling out silty sand material, a little bit of cohesion in the base. I'm going to leave the others at 0. 5.4 degree batter for the block, pre-programmed, 6-inch leveling pad, 6 inches of embedment, 10% base to height ratio. I'm going to design for slope embedment. For a 3-to-1 slope is H over 10, 2-to-1 slope is H over 7. We'll input those, we'll put the checkpoint. I want the circles, the point's a little larger, and we're going to offset it 5 feet from the top of the wall. We'll see that. You don't have any seismic, 60% base to height, 4-foot minimum grid, 2.67 maximum spacing. The program is going to default to 2 times the block depth, so it will default to 2 feet. So we come back here, we'll shrink that screen down, I'll put it over here. Let's draw the wall. This is checking. I did my surcharge loads, I did my slopes, this isn't seismic, we're good to go. We're designing the wall. And there's the wall design. We can zoom in on it. We've got 10-foot grids through here, stepping another 9 feet. As we've got a slope in front of the wall, our embedment increased from 6 inches to looks like 10 inches to a foot as we come around there. Top of wall, we got a little step as we come around the corner. We step down, we grade back up. Let's look here in the corner. Remember, our slope started over here at this corner, increased the most at this corner outside, and then decreased as we came back up here. And you see that our embedment is increasing and decreasing, both with height and with the slope. So we go to station 112. Station 112. There's our geometry. There's a slope down below the wall. There's a surcharge above the wall. We can look at global stability. 1.5, we're good. remember this slope was short. It was only about 6 feet, went off the property line. So we're modeling just what we're seeing in there. We can go back to static results. We can go back to the very first section of the wall. Now, if anything is not correct in this table, these first rows will be highlighted. Also, anything down here will say no good. We can just step through the wall. Everything's looking good. You know, if we want to stretch this across, we can see more of the table. But everything meets the design. 74, up there. Yeah, we're good. 104, 141. Remember, this will highlight yellow if anything is wrong in the table. Say I type this one and my top grid is short. Highlights it in red to show you there is a problem. We go back through, we lengthen that grid back out. Go to the end of the wall. Yeah, everything's looking good. We can shrink that down a little bit. Go back up to our view here. You know, what we like to do when we come across is, I don't like to see the grids jumping so much, 8 foot, 9 foot, 10 foot. We could expand those grids out and even them up. If I go to the right, right here, we go to station 113. 113. This looks good. I like to see a grid 2 down from the top, preferably 2 up from the bottom of the slope. I'm going to leave it down there. But I want to extend those grids over so they're level. I can either go to the next section, and I could go to static design. I can remove that bottom grid, Control Delete. There we go. I've removed that bottom grid. Now if I update design, see everything moves across. If I wanted the grids the same length, I could have come back to this station 112. These are 10 foot. I hit the right button up here, and that will update it. And we can just move across. So eventually, not taking too much time, I can go down here to station 191 and do the same thing. 191, I can move the grids up, update the view, things line up, we can move the grids up and down, get the drawing like we want it. Say we're done with the drawing, we can look at our quantities. And this counts the blocks themselves, the labels. So we've got 188 cap units, 1,840 wall units, and I got 4 half blocks. Half blocks being at the end of the wall, we're stepping up here. Total of 1,936 square feet. We had some contingency of the walls, and there's a 282 feet in length and cap length, 2,000 square feet. Our geogrid, this is all Stratagrid 200 through here, 847 square yards. There's a contingency there to be the total. If we look down on this table, that 1 foot of stone behind the unit is 68.6 cubic yards, and the backfill material was 573. We've got our quantities. We can now print our estimate with the elevation view. Let's say before I just do that, we didn't do the project information, but we can say trial project, your initials, the state, home location. Gives us some information. We need to update the design so that goes in the record. We go back here, we print our estimate, long view. There we go. There's our wall. There's our elevation points printed out. There's the name of our project, the designer, location. If you put it in, elevation view, your input properties, your leveling pad. Here's the block count, the number of units, the number of square feet. Here's your grid, total square yards. There's a table of fill zone, those 2 numbers we talked about. Text of what the program is doing. There's your input data. print that to a PDF, print it to the printer, send it out. If we now save our file, the analysis is a two-dimensional. This is a design. So we save our design. I'm going to put it up on the desktop, and I'm going to call it sample design. The file is saved. If I shrink the file, is saved. And it's actually on the other desktop. So there's that. And there's the AutoCAD file that that was a lot of details we just ran through. It took a little longer than I wanted, but it really shows what you can do here. We import the drawing, we copy off the wall, we input our surcharge load, our soils, our block type, we draw the wall. Ends up, we have a full quantity takeoff on a full AutoCAD drawing ready to go to the contractor or ready to go to AutoCAD and put some details on it. So save a lot of time. Wall like this we should be able to do in about 15-20 minutes in and out. So saves a lot of time. It's worth looking at. Give me a call to get the software, and I'm sure that you'll like it. Thanks.